Okay. Yeah, it is a nice thing, Pythagoras. There's two things in Pythagoras, really, that we need to know. We need to find out, number one, the hypotenuse, or number two, one of the shorter sides. So we're going to go through first about finding out the hypotenuse. All right. So, Pythagoras theorem. So we've got the hypotenuse. Now, the hypotenuse is the longest side of a right-angled triangle. All right. And as you can see, it's always opposite the right angle. Yeah. So it's the longest side and it's always opposite the right angle. The right angle is always depicted by a little square corner. So, what does Pythagoras theorem allow us to do? Well, it allows us to find the length of any side in a right angled triangle when we know the length of the other two sides. Okay, so in this example, we've got the two shorter sides. Okay, one is 8, one is 6. We're not going to bother about units just for this time, just for this example. All right. So we've got 8, we've got 6. We need to work out what this side is. Okay. Now, this is the formula we use. So it's a squared plus b squared equals c squared. Okay. C squared is your hypotenuse. There we go. Popped it on there for you. Okay, now a squared, there we go, and b squared. So, our a squared, okay, remember 8 isn't squared at this moment in time. It's just a number, so it's a squared. And then we're adding that to b, which is 6 squared. And that will give the answer c squared. Okay, so 8 squared, 8 times 8, remember, a squared number is multiplied by itself. A number multiplied by itself, not multiplied by 2. So 8 times 8 is 64. Then we're plussing 6 times 6, which is 36. Okay. Add those two together, we get 100. So 100 equals c squared. Okay. Now, this 100, remember what I've just said, is c squared. We obviously don't want it squared, do we? We just want a measurement. So what we have to do is we have to do the opposite to squared, which is a square root. All right. And you've probably seen that symbol on your calculator. All right. So if you put 100 in your calculator and then press that symbol, or press that symbol, then put 100, it depends on what kind of calculator you've got, you'll get the answer 10. So that is the square root. So it's opposite of a squared, square root. So we're square rooting 100, and that gives us 10. Okay. So 10 equals C. So C is 10. Just before I move on, something like this you could get in a non-calculator paper. Okay. Something as easy as that one. Obviously, if it's not going to be something that you can't work out the square root of. Okay. then it's going to be on a calculator paper. But usually, if it's a non-calculator paper, it's usually like working out the square root of 100. All right. So what I want you to do, I want you to work out the hypotenuse here for me. So have a minute or two just to think how you do it. Use your calculators, I don't mind. Work out the square root. Work out the length of this hypotenuse. Okay. I'll give you a couple of minutes to do it. And then put your answer in chat once you've done it for me. Thanks, Martin. Cheers, Jack. Cheers, Dahlia. Cheers, Megan. Okay. So yeah, everybody's fine with that. Now, what I suggest is, I know you've all rounded that to 2 decimal places. Okay. You've all put 7.21, which is right. Okay. Now, if you used a calculator for that, yeah, you would get 7.2111025509. What I would do in an exam is I'd write all those numbers down. If it doesn't tell you to round to a certain decimal place, like you've all rounded to 2 decimal places, yeah, just put down whatever it shows on the calculator. That goes for any question, especially if it's a calculator paper question. Okay, that's where some people lose marks, because they don't write down what's exactly on the calculator. Obviously, if it says round to 2 decimal places, 3 decimal places, 1 significant figure, 2 significant figures, whatever, then you do that. Okay, but always write down the actual number, what's shown on the calculator. Okay. So yeah, we've got 4 squared plus 6 squared. Okay, which will give you c squared. We've got 16 plus 36. Okay, which will give you 52. Square root your 52. And of course, to 2 decimal places, you'd get 7.21. Okay. To 1 decimal place, it'd be 7.2. So, I'm going to let you have a go at these. Yeah. Again, it's just finding the hypotenuse. There's no trick questions. Now, you can either write these in the chat, or you can write them on some paper, and then we'll go through them after. Okay? Um, yeah, you can round them to one decimal place if you want. But remember, when you're working them out, write down the full number. That's what whoever's examining your paper will want to see. So either one decimal place or two decimal places. I don't mind really. Like I said, if you're doing it on paper, just give me a shout in the chat and tell me when you've done. Excellent. Cool. Okay. Excuse me. So I've rounded these just to two decimal places. Okay. So of course, the first one, we've got 9 squared plus 5 squared equals c squared. And I need to find out what x is. Yeah, x just stands for the hypotenuse. So I've got 81 plus 25, so they're squared. 81 plus 25 equals c squared. C squared is 106, so I need to square root that. So x, or the hypotenuse, is equal to 10.30 to 2 decimal places. The second one, we've got 7 squared plus 4.8 squared equals c squared. Now, again, this is something that will be on a calculator paper because we've got that decimal point there. All right. So your 7 squared will be 49 plus your 4.8 squared, which will be 23.04. That will give us c squared, which is 72.04. We then square root that, and then x, or the hypotenuse, would equal 8.49 centimeters to 2 decimal places. If you've done it to 1 decimal place, that will be 8.5. Okay. Number 3, again, we've got 3 squared plus 5.1 squared. Okay. So 26.01 plus 9 equals 35.01. We then square root that answer, and x, or the hypotenuse, should equal 5.92 to 2 decimal places, or 5.9 to 1 decimal place. And finally, number 4, we've got 16 squared plus 13 squared. 16 squared, 256, plus 13 times 13, 169, will give us 425. Remember, that's squared, so we need to square root it, just to turn it back into a length. So x, or the hypotenuse, would be 20.62 centimeters. Okay. To 2 decimal places. To 1 decimal place, that would be 20.6. Okay. Now, the next bit, this throws people off because it's finding the shorter side. So, let's have a look. When we're working out the shorter side using Pythagoras theorem, okay, we have to rearrange the equation. All right. So remember, we had a squared plus b squared equals c squared. So it will be 3 squared times x squared equals 5 squared. Now, we can't do x squared, can we? Because we don't know what x is. So we can't use that formula. We have to rearrange it. Okay. So we've got the a there. That's the one we need to find. A is now x. Okay. This is the formula we had before. A squared plus b squared equals c squared. So what I'm going to do this time, I'm going to change this formula around so that instead of that 5c, instead of the c squared, the hypotenuse, okay, being the subject, all right, I need the x to be the subject. Okay. So what I'm going to do this time, I'm going to take a squared and pop that down. Now, I know that that added to that equals that squared. So what I'm going to do it reverse. I'm going to start with that. I'm going to take away that, which should give me that. Okay. Now, if it was the other way around, yeah, and I had that, and I had that, but I didn't have that, I'd do exactly the same. I'd start with my hypotenuse. I'd take away whatever this number is, which will give me this number. Okay. So let's have a look at an example. So this is the new formula. A squared equals c squared. Take away b squared. Okay. So my a squared is c squared. So that's 5 squared. Take away 3 squared. My 5 times 5 is 25. 3 times 3 is 9. So I've got a squared equals 25, take away 9. So 25 take away 9 is 16. Remember, it's still squared. So what I need to do is I need to square root it. So I square root 16, which gives me 4, because 4 times 4 is 16. Okay. Is everybody happy with that? Does that make sense to everybody? Yep. Yep. Cool. Again, I'm going to give you a few more minutes to have a go at these now. Now remember, you're not working out the hypotenuse. Okay. You're only working out one of the shorter sides. Again, there's no trick ones in here. You've got no sly, work out the hypotenuse in them. They're all shorter sides. And again, just write down in the chat once you've done for me. Cheers, Martin. Cheers, Dahlia. You all right, Mike? You all right, Jack? Cheers, Megan. You done, Jack? Nice one. Okay, so again, number one, we've got 17 squared minus 8 squared. Okay, that will give us x. So 17 squared is 289. Take away 8 squared, 64, which gives us 225. We then square root 225, and we get 15. So it's 15 centimeters. The missing side. Number two, you've got 9 squared, which is 81, minus 6.4 squared, which is 40.96. Okay. That gives us 40.04. We square root that, and we get 6.33 centimeters. That's 2 decimal places. 6.3 to 1 decimal place. And sorry, the first one would be just 15 because there's no decimal places there. If you did it to 2 decimal places, it'd be 15.00. Just a thing to point out, if it says 2 decimal places, yeah, and your answer comes out at 15, please still put 0.00. Okay, even though there aren't any numbers, if it says 2 decimal places, it still wants the zeros in. Okay. Number 3, so we've got 24 squared, which is 576, minus 19 squared, which is 361, gives us 215 squared. That's squared. We square root it, so square root of 215 will give us 2 decimal places, 14.66 centimeters. To 1 decimal place, that will be 14.7. Finally, D, we've got 31 squared, okay, minus 25 squared. That will give us a total of 336. Obviously, that's squared, so we square root it. So square root of 336 is 18.33 centimetres to 2 decimal places. To 1 decimal place, that will be 18.3 centimetres. How did we all go on those then? We okay? Yeah, good. Yeah. Anybody have any problems with those? No. Cool. So, again, this is where people fall down with Pythagoras when we get worded questions. Now, obviously, with GCSE nowadays, there is a functional element to it where they give a real life situation and you're expected to find out what you need to use for it. So, this example, a plane leaves Manchester Airport heading due east. It flies 160 kilometres before turning due north. It then flies a further 280 kilometres and lands. What's the distance of the return flight if the plane flies straight back to Manchester Airport? Now, with a question like this, if it makes it easier for you to visualize it, draw it. Okay? You don't have to draw the measurements exact. You can just write the measurements on there. Okay? So, let's break this question down. A plane leaves Manchester Airport heading due east. It flies 160 kilometres. Okay, so there's your plane. It's going east 160 kilometres. It travels to there. Okay. Again, like I said, don't worry about the size of the line. Just make sure you put down the measurement. Now, it says there before turning due north. So north, always up, isn't it? It then flies a further 280 kilometres and lands. So it's gone up. So it's gone east, 160 kilometres, and then it's turned north and gone 280 kilometres. Okay, so we're there now. It then says, what is the distance of the return flight if the plane flies straight back to Manchester Airport? So there's Manchester, that's where we started. We've gone there, we've gone up there. Now, if he flies straight back to Manchester Airport, he's going to go the shortest route, isn't he? That way. He's not going to go that way and that way because that's not straight back. Straight back is the quickest way. So it's there. Okay. So this is what we're wanting to find out. Again, remember, opposite the angle is the hypotenuse. So we know this is the hypotenuse. And it's obviously the longest side, isn't it? Cheers, Martin. So we've got a squared plus b squared equals c squared. So we've got a and b. It doesn't matter which way around we have these. Okay. If you're panicking, thinking, oh, how did you know that were a and how did you know that were b? It doesn't matter. Okay. So my a squared, 160 squared. Okay. Plus my b squared, so 280 squared, equals this one, my c squared. So I've squared that one, I get 25,600. I've squared 280 and I've got 78,400. Add them all up together and I get 104,000. Yeah. Obviously, I need to square root that. So I square root 104,000 and I get, just like Martin said, 322.49. So it's 322.49 kilometers. Okay. Is everybody okay with that one? Have we gone through that word question? Yep. Yep. Right. Obviously, Martin's all right because what answered him. So I want you to have a go at these questions now. Okay. I'll read them out for you. Give you a few minutes to have a go at them. So, question number 1. A ladder 12 meters long leans against a wall. The ladder reaches 10 meters up the wall. How far away from the foot of the wall is the foot of the ladder? Okay. This is a typical exam question. I've seen this on exams on GCSEs quite a few times. It's one of the questions that people look at and they say, "Oh, I can't do that," not realizing it's only Pythagoras. We've got the hypotenuse there, and we've got, let's say, A there. So it's B we're working out this bit here. Number 2. How do you know if it's a plus or a minus in worded questions, Dahlia? Good point. Okay. Remember, if we've got the hypotenuse, then it's going to be a minus. If we're working out the hypotenuse, okay, then it's going to be a plus. Now, we can tell we've got the hypotenuse because remember, opposite the right angle is the hypotenuse. The right angle will be there. Yeah? So opposite that is 12. That's right, Martin. You have to visualize the shape of a triangle and make the points in your head with the number. That's a good point. Yeah. Most of the time, they show you the image. Just like before, though, in the other one, in the last question, if it doesn't show it, yeah, just draw a quick sketch of it. Yeah. Yeah. So, like I said, just draw a quick sketch. Just follow the instructions, draw a quick sketch. So this one, a model of a football pitch is 2 meters long and 0.5 meters wide. How long is the diagonal? Okay. So for an example, if I wasn't given this image here, because that's showing you the diagonal there. If I wasn't given this image and I just had a football pitch is 2 meters long, so I know I need to come across 2 meters. I know that it's 0.5 meters wide. So it's going to be, the width is going to be 0.5. Now I know a football pitch is rectangular, isn't it? Yeah. So this measurement, the top measurement, this measurement here is going to be the same as that. And this measurement here is going to be the same as that. So I just draw a quick sketch. And then obviously my diagonal would go from there to there. If you do your diagonal, yep, no problem, Dahlia. If you do your diagonal from there to there, it's still going to be exactly the same as from there to there. Okay. Again, some pedestrians want to get from point X, one road point. Some pedestrians want to get from point X on one road to point Y on another. The two roads meet at right angles. So I know X and Y meet at a right angle. So it's going to have that square there where they meet. That's that. Okay. So X and Y, and there's the right angle. If they follow the roads, how far will they walk? So if they follow this road, X and Y, how far will they walk? Well, they'll walk 33 meters that way, 94 meters that way. That's the first bit done. A. Instead of walking along the road, they take the shortcut, X, Y. Find the length of the shortcut. So I'm looking for the shortcut. X is there, Y is there. So this is the shortcut. Now look, it's the hypotenuse. All right, find the length of the shortcut. So I know that squared plus that squared equals that squared. So once I've got that, square root it, and then that gives me my answer. How much distance do they save? Okay, so I'm looking for the difference, aren't I, between that and that plus that. So remember, the biggest number, take away the smallest number for the difference. Now just give me a shout on chat once you've completed those. We'll move on to the answers. Cheers, Martin. All will be revealed shortly. So let's have a look. This one, X equals 6.63. So well done, Martin. Okay. The diagonal, which is X in this case, is 2.06 meters. Remember to put your unit of measurements. Yeah. And finally, your last one is for A is 127 meters. For B, it's 99.62. Okay, which is what you did, Martin, I think. And for C, the distance to save. Okay, so we've got 127 meters if we went that way and that way. We've got 99.62 meters if they went that way. So it's the biggest number, 127. Take away the smallest number, 99.62, which would give us 27.38 meters. Okay. Do we think we could tackle some questions on that? Yeah. Brilliant. Well, what I've done on Maths Watch, I've set you some questions. There's only about 6 questions, something like that. Yeah. Shouldn't take you long to do, as long as you know how to do it. I'm going to let you do that for the next 10 minutes. If you get stuck, give me a shout, jump back on the meet, and I'll help you out. Okay? Cool. And if you've got any time left, then have a go at some of your ILP work. We need that stuff out of the way. Is that okay? Okay. Marvelous. Right, get on with some. You can come off this chat if you want, and get on with your Maths Watch work, or if you want to stop on it just in case you need help, that's fine, or jump back on it. I'll be here while 10 o'clock. All right? Right, guys?
I finished Maths work.
Good lad. If you finish your Maths Watch stuff, for next 5 or so minutes, you can just do some ILP work for me, Martin. Is that all right?
Yeah.
Good lad. Okay. Has anybody else got any questions?